So, continuing on with solving linear equations, again, when you solve a linear equation, your goal is, again, you're trying to find the value of the variable that makes each side equal. In doing that, though, we have strategies. The strategy is keeping the equation balanced. To keeping the equation balanced means what you do to one side, you can do to the other. Now, as we move forward, though, before we can start moving things around, each side of the equation must be simplified. So to simplify, this is where we're talking about combining like terms, removing parentheses, those types of things are simplifying. So in the end, we want anything that can go together on each side of the equation, we want to put it together. So we have to understand that. So then we need to get the variable on the same side of the equation. So this is where I refer to as pick on the little guy. So once we get the variable on the same side, then we want to move the numbers opposite of the variable. So they want to go on their side of the equation, on their side with the variable. And then we want to get the variable by itself. So that means we want to make the coefficient of the variable 1. So the coefficient of x, or the coefficient of whatever the variable is going to be 1. So this is where we use multiplying and dividing. And so once we get x by itself, we have our solution. And a lot of times in your homework, we have the set notation. Remember, in the set notation, only the number only inside here. So check the solution. And sometimes, if it doesn't seem to work, watch out for those special cases. We may have something that's a no solution or infinitely many solutions, or the set of all real numbers. So that's kind of the checklist we can use in solving linear equations. Let's look at an example. So solving this equation. So we have 8 minus 4 is equals 8. One thing to pick up on is this a linear equation? Well, to be a linear equation, we look at the terms. Notice how 8 is a term, negative 4z is a term on the left side, and on the right side, 28 is a term. So notice that, remember, the degree of the 8 is a 0. Since z is a variable, notice how, since there's only, when you just have z there, that just means there's a 1. Now remember exponents, in talking about exponents a little bit. So if I give you, say, 3 to the power of 1, that just means there's 1 3 present. But if I give you 3 to the power of 2, that means there's 2 3 presents, but these are connected by multiplication. That means 3 times 3. So if I gave you 3 to the power of 3, this exponent means 3 times 3 times 3, which would indeed be like 27. So that's 9. So remember, an exponent tells you how many of that number are connected by multiplication. Remember the coefficient, if I gave you 2 times 3, the 2 tells me that there are 2 3's present. That means 3 plus 3. So if we look at this from a variable perspective, z to the first just means there's 1 z present. Z to the second would mean 2 z's present, but they're connected by multiplication. Z to the third would mean z times z times z. There would be 3 z's present, but they're connected by multiplication. So don't forget, an exponent has a different concept in it. It's a shortcut for writing repeated multiplication, where multiplication can be considered a shortcut to repeated addition. So notice how here a number has a degree of 0, but since the variable has, you don't see an exponent, it's understood to be a 1. That's a degree 1. And again, we have a number that's a degree 0. So from that perspective, this is a degree 1, and that means this is linear. How many solutions are possible? So keep that in mind, that the most solutions possible would be typically would just be 1, unless it's those special cases. Then we have a different thing. So notice how ax plus b is equal to c. That's typically what we want to begin with, if possible, because this is the easiest type of linear equation to solve. Notice that x is our variable, a is a coefficient, b is going to be a constant, and c is going to be a constant. So we have that kind of going on here. So if I look at my equation up here, if you want to, you can rearrange this left side to be negative 4z plus 8 is equal to 28. Because remember, terms can be rearranged because this is addition. So if you don't like 8 and a negative 4z, you can write that as negative 4z plus 8 equals 28. So from there, negative 4z and 8 are not like terms, and 28 is already simplified. So it is simplified. Notice also the variable is not on both sides. The variable is only on one side, so that's kind of done for us. So really now, we're just trying to start to move things around. So the next thing is we want to get this number away from the variable side. So to get rid of an 8, we have to lose an 8 or subtract an 8 on both sides because that will turn into a 0. I can't read the other side there. What the heck is that? So I want to subtract an 8 here. So I draw a line to say, hey, what's my new equation? So my new equation is going to be negative 4z, and 28, and we lose an 8 would be 20. Now, to make the coefficient go away, in other words, we want the variable to be by itself, so this coefficient's got to go away. Since it's connected by multiplication, we can use division to cancel it out, if you will. So we can divide both sides by negative 4. Now remember, a negative divided by negative is a positive, and that means this turns into 1z, or simply z. And 20 divided by negative 4, notice that 20 divided by 4 is 5, and since there's only one negative present, that means it's going to be a negative 5. So that means our solution is going to be negative 5. So our solution set can be written as this. So notice how we do have one solution. That means we don't have to look for any more. So if I look at this next example, notice how it looks a little bit more complicated. But if we use the strategies, we can solve this. First thing is just make an observation. This is degree 1. This is degree 1. A constant's degree 0. A constant's a degree 0. This term is degree 1. This is a 0. And this is a 0 as well. So since the biggest degree was 1, we know this is linear. So we know that there could be up to one solution possible unless it's a special case. So now that we recognize that it's a linear equation, we start to combine like terms. So notice that this 11x and 15x, since these are like terms, we can just add the coefficients, and I believe that's 26x. And notice that the numbers can be added together, so a negative 6 and a 5. So I'm in debt 6, but I paid off $5 of debt, if you will. I'm still going to be down 1. So remember, you can subtract 6 minus 5 is 1. And remember that we're more negative than positive, so the final answer's got to be negative. On this side here, the negative 9x does not have anything to go with. But notice how we have a 5 and lose 6, or 5 and a negative 6. So notice how we're going to be losing more than we have, so we're going to be down 1. So we have a negative 9x minus 1 on that side. Now we simplified each side, but notice how the variable is on both sides. So this is where I like to pick on the little guy. So between a 26x and a negative 9x, I consider the negative 9x the smaller one. That's my strategy. So you got to pick on one of them. I always pick on the smaller one. So to get rid of a negative 9x, I need its opposite. So I need to add a 9x, so that would zero out. But to balance the equation, I have to add a 9x over here. And this is where I draw a line to say, hey, let's put this all together. So I'm going to bring it down the page. So 26x and a 9x, that looks like that's going to be a 35x. And then we still have a minus 1. And over here we have just a negative 1. So now we got the variable on one side, but we need to get the variable part by itself. So this number here has to move to the other side. So this negative 1, if you will, if we're talking about terms, has to turn into a zero. So if we see a negative one, we can add a one, but we have to add a one to both sides to keep it balanced. So this ends up being 35x equals, looks like zero on that side. Now, to make the coefficient one, we need to divide both sides by 35. So we know that we get x equals, but what's 35 divided by zero? So again, 35 divided by zero, I'm sorry, that's not what that's saying. So try that again. This is saying zero divided by 35. Oops, lost my problem. Where'd it go? There we go. Sorry about that. So this really says 0 divided by 35. So really what this can say is how many 35s does it take to get 0? Or you could say 35 of what gives you 0? And also 35 zeros would give you 0. So when you have 0 divided by 35, that just turns into 0. So my solution set would be then 0.